draw each of the functions in the domain. So in the domain means this is your list of inputs from -2 up to 2, where we have x can be any real number between -2 and 2. So it could be -1.9999, or it could be up as far as 2. So it could be 1.543, whatever, because it can be any real number. So when I plot these points, I better join my points together. I hope that makes sense. If it doesn't, just make sure that you ask questions. I can do other videos to clarify. So here's my function. You can put it into your calculator. 10x minus 4x squared. Do I want to start at 1? No, I want to start at -2. Do I want to end at 5? No, I want to end at 2. And do I want to go up in whole numbers? Yeah, I'll go up in steps of 1 whole numbers. So we have -2 minus 36, which is off down here. We have -1 minus 14. We have 0, 0. 1, 6. And 2, 4. Okay, so if I had z, x was an element of z, I wouldn't join them, but I have x can be any real number, so I'm just getting the outline using the whole numbers, but I'm going to connect all that now. Oh, this is why you use pencil and not a pen for your diagrams. Now, I would input that here, all my points that I plotted, because if I made a mistake, you know, whether it was inputting into the calculator or anything at all, I want to show them some work, unless I don't have time. If I didn't have time in the exam, that's different, but I do have time now, so that information there, all those points would be written here. And I would go and now do the same thing for here. 3 to the power of x. Sorry, no. 3 to the power of x. Do I want to start at -2? Yes, I do. Do I want to go up to as far as 2? Yes, I do. And step 1. Steps of whole numbers. So -2.1. So that's about there. -1.3. 3 is a little bit higher up, but only just barely. 0, 1. 1, 3. And 2, 9. Okay, that shot up pretty quickly. It's like any graph that you'll see for the COVID. It's shooting up pretty quickly. So this is an exponential function here. Just means that the missing thing is a power. And again, I don't have a pencil here, but I'm just doing my best with what I have. So take your time, fill that in. And as I said, if I had time in the exam, that would absolutely go here, just to show them what I was doing, how I got this. And in case I made a mistake pushing buttons in my calculator, I would get a lot of marks just for having it done. Graph the following inequality on the number line. Okay, so it's a real number, which means it could be any number between here and here. So like it could be decimal, a fraction. Can it be the number 2? Yes, it can, because it's equal to the number 2. So I better fill in the number 2. And all the way back now, all of these are getting filled in. They're all possible answers. Can it be -2? Yes, it can. Can it be -2.5? Yes, it can. Can it be -2.99999? Yes, it can. Can it be -3? No, it can't. It's not equal to -3. So I'm going to show this by doing an empty circle. So it can be anything up as far as -3, but it can't be -3. And here we want to use algebra to solve the following inequality. So what I do to one side, I do to another. So I'm going to subtract 8 from every side. Now there's another way to look at this, but this is, I feel, the most straightforward. If you want it done a different way, if you feel like this isn't the way you'd like to do it and you'd like to see a different way, just make sure you say. I don't like the fact that I have a minus g when, if I'm solving, I'm going to get the missing number by itself. Now, not minus the missing number, not minus 3 times the missing number, but just the number. So I'm going to multiply by a -1. I'm going to multiply everything by a -1. And when I do that, in order for the statement to remain true, and you can test this out with real numbers, I need to change the sign of everything. Now I'm going to divide by 3. And I have 15 g -1. Now if you want to write that the other way around, you're more than welcome to. But both of these are correct.